So for the NIME challenge, what I did is a sentiment analysis of one movie review data set. First, let's look at the data. You can see from the data preview, there is a row ID for every row, and there is the index, and also there is the URL link for the specific movie, and also there is a tag, and for last one is the sentiment label. Like for this dataset, it contains 1,000 of positive and also 1,000 of negative labels. Okay, so let's apply it and run it. And then what I did is to convert the screen to document so that I can use filter to filter all columns except the document column. And what I did after that is mainly text processing. It involves like 6 steps from punctuation erasure, number filter, then char filter, subword filter, case converter, and also snowball stammer. For the punctuation erasure, what I did is to remove all punctuation marks, and then for the number filter, I remove all numbers from the data, and then I remove words less than 3 characters so that like all the remaining characters will be like long sentence and long words. And the stop word filter mainly remove all stop words that are already built in this node. And for the case converter, I just simply convert all words from no matter lower or high capital case to the lower case. And then I use the snowball stammer. It's a node that allows you to stem terms by the stammer algorithm provided by the snowball stammer library. I think from my research, it's one of the stammer methods that you can use. So I chose this one. Okay, let's run it. And then after the snowball stammer reduces word to word stem, then I did transformation is to build a bag of words, and then I convert terms to strings. Then we are entering the pre-processing step. For the pre-processing step, what I did is to capture the term frequency and also then group by the terms as strings. And you can see the group by node groups the row of table by a unique value in the select group columns. And then I use a row filter to keep only terms occurring in more than 20 documents. I did that because like the total number of the documents will be 2,000. So that's why I think maybe a word or term that's occurring in like 1% of the total document will be a reasonable amount. Yeah, let's run it. And then I use another reference row filter to filter the bag of words to applicable and practical build W. Yeah, and then this document vector creates a document vector for each document representing it in the term space. And I think this is a key step in this workflow because it's basically represents the values of the feature vectors, and it can specify it as a Boolean value or as value of a specified column. Yeah, that's right. Yeah, because this is the one that creates a bit vector for documents, and it might take a longer time. And then I can extract sentiment labels like from category to class. Yeah, I think we can look at the document output table. Yeah, as you can see, like all of the color of the row ID will be the same one, but for the next node, the color manager, I'm gonna assign different color to different to different row. Like as you can see, I'm gonna assign negative as a green, but also I'm gonna assign positive to a red label. Yep, let's do it. Yeah, you can see from the table with colors. Yeah, like from the for the row ID, the negative one is gonna be green. But for the positive one, it's gonna be red. And then we enter the step of model and classification because I think this is a supervised learning. That's why I'm gonna use decision tree model and also SVM model both to compare their results. And basically what I did here is to partitioning the dataset to training and test set. And then I'm gonna use the decision tree. I'm gonna use both the learner and also the predictor to see the score and the accuracy stats. Yeah, let's do decision tree first. Yeah, for the partitioning, I'm gonna split the whole data set to 70-30. It's like 70% of the data set is gonna be training set, and the remaining 30% of the data set will be test set. And then we are gonna run the decision tree learner. Yeah, yeah, this is a step that we are going to build the decision tree model. And you can see from the decision tree learner that there is that's a tree. And yeah, I'm going to run the later decision tree predictor. And that's when we can get the result of the RC curve and also the accuracy stats. Yeah, you can see from the RC curve, like it's about like 89% or like 90%. Like yeah, like here the talking class for positive is gonna be like 90% per se. And for the accuracy stats, yeah, it's just like another way to show it. Like there is data for the accuracy stats, it's gonna be like 89%, and also it's gonna be 10% of the error. And for the SVM model, it's basically the same thing, but I'm gonna only use the accuracy stats to show the results. Yeah, this SVM model is gonna take longer time than the decision tree model. And I think that's pretty much because the string tree for the support vector machine for the input data. And because it supports a number of different kernels, I think that might be one reason it might run longer time than the decision tree model. And this is the one that chooses a column that contains a nominal target variable, and it can use in the different steps. And then I can run the predictor. And this is also going to take a longer time, but this is going to use the model that's generated by the SVM learner so that we can get our result. Yeah, let's run the accuracy stats. And yeah, I think I don't know what's going on from here. But basically, from what I did previously, the SVM model predicts a little bit lower result than the than the decision tree model. So I think in this case of the sentiment analysis, decision tree model might be a better option. Yep. And that's it. Thank you for watching my video. And if you have any questions, you can contact me. Thank you.